things and add them to TDAS automatically.
Question about the part that you said that it runs slow, so one possible mode forward was creating CDF.
Yeah, we're definitely going to do that. It's
What
like,
do you mean by that?
well, I mean, we were looking at reprocessing the whole mission on a single core computer, just using, and it was going to take, I think, 1.3 years to do all of the Themis data. So that's what I mean by that. So if you want to be able to just, but if we put it in a CDF with the processing already done, then you can just pull it and have it, you know.
Okay, so it wouldn't be done on my machine, and then it would take a while to do it the first time, and the next time it would pull up, it would already be another data product.
Yeah, or it would actually just grab the CDF from our website. So yeah, and then yeah, the CDF would be stored on your computer, so it would be quick. Right now, if you use the command line tools, like if you're interested in a narrow time interval, it's no problem. You know, maybe you have to wait, you know, a couple of minutes. But if you want to do a wide time interval of data, that's going to be some long waits. Or what we're going to do for our CDF processing is we're going to have a fancy computer that has lots of cores. And, fancy-ish, yeah. But so that we can do it maybe in a month instead of 15. So these are all the people, or a lot of the people that have contributed to. There are actually a lot more, but this is sort of various team members that have worked on this over the last 10 years. So just a basic overview if you're not familiar with Themis spacecraft and our acronyms. We have EFI, which is these radial booms that come out and measure, they're wire booms and stasers that measure the electric field. FGM, which is a flux gate magnetometer, SCM, surge coil magnetometers. And then we have the two particle instruments, which are the ESA, which is our lower energy particle instrument that measures electrons and protons, and the SST, which is our higher energy particle instrument, also for electrons and protons. We also, as part of the Themis mission, have ground-based products. So we have a ground network of magnetometers and all sky imageters. So this is sort of shows the ASI locations, and we really expanded. We brought in a lot of other data sets that you can get access to now from TDAS, so you can get just a ton more GMAGs, and like in the last presentation, you can get like superdark radars and stuff too. And then we also, these are processed products that are generated on the spacecraft. So filter bed, which grabs from particular instruments, it'll grab a narrow range of, it'll do a bandpass of a narrow range of frequencies. This is spin-fit products that are at the 3-second resolution of the spacecraft, of the Themis spacecraft. Fast Fourier transform, so that's a frequency decomposition spectrum. Onboard moments, so they're sort of calculated right away, so they don't have all the calibrations, but they're high time resolution. And state, which is ground computed, which is just our FRS. I don't know if people aren't familiar with this, we have a couple of different data level definitions. So as we process the data, we take it through these different levels. Our level 0 is basically is completely unprocessed. It's fairly, not completely, but it's not really in, it's not even integers, it's just sort of binary files off the spacecraft. Level 1 data is in an intermediate state, so we break it out from just a single sort of binary file into CDFs that contain integer values, and then we can use the software to calibrate that, use the most up-to-date calibrations. So sometimes we'll talk about level 1 and level 1 calibrated, which is using the TDAS software to apply the newest calibrations to generate level 1 calibrated. And then our level 2 is basically we take that level 1 calibrated and we put it in a CDF and include all of the metadata that's really needed to understand this. This is what you'd see on SPDF, would be our level 2 data for the most part. So this is sort of our, this is our status as of now. I'm not going to read this whole thing. I think I mentioned the big changes that we have. More GMAGs. Now we have the moments in the SST level 2, and So just how do you get the software? Let's see. So you go to the FEMIS website. Can't quite read it, but it's femis.ssl.berkeley.edu. Oh yeah, wait, down here. Beautiful. And you click on the software drop-down, and then you get a page like this, and you can just click the download link, and that'll take you to a place to download it. We have links to documentation. We have a quick reference guide if you want to get started fast, and a sort of more lengthy user's guide. We have HTML documentations with documentation for the command line procedures. We have a wiki, which is it's a wiki. And we also, you can get what the developers are working off of, or like within 24 hours of what we've been working on. So it's called the bleeding edge every 24 hours. Or faster if we add a new feature and you want it fast. Sometimes we build them in the middle of the day. But it's sort of it's a copy of our repository as up to date as possible. If you have issues, if you have bugs or you want features, you can email us here and we'll get back to you very fast. And depending on the complexity of the feature, we'll fix it. Sometimes quickly, sometimes it's years worth of work.
But a lot of those inquiries do end up being implemented as features. So if you're not sure about anything, or if there's something you'd like to see, by all means, please write us, and we'll get it all in consideration.
This system is supposed. This system is supposed Windows and Linux.
Oh yeah, I think that we might have mentioned that in the last presentation. I don't know if it's in here, but we support.
The source code distribution supports any system that you have an IDL license for. We do have other alternate distributions. In particular, we have an executable distribution, which does not require any IDL license at all, but we have to build that for each specific platform. So for that one deliverable, we support Windows, Mac OS, and Linux.
So if you have an IDL license, no matter what system you're running on, you can download the software and run it on that license.
You need to have IDL 6.4 or later. And for some of the plugins that people are developing, they're using newer IDL features. So then, but for the core TDAS and SPDAS software, we try to maintain backwards compatibility to 6.4.
If any of the folks are seriously interested in FEMIS data, probably you are here. And if you don't have an IDL license, we are willing to give you one temporarily. We've got 100 licenses. So we'll give you one to use it.
Is it possible if we don't have license?
It's possible to use this virtual machine, which doesn't allow you to use the command line, but you use the GUI and also commanding within GUI, which is what we call the mini line, which already is very powerful. You can do a lot of data processing like that.
So one of the newer things we've got now, and you can link this off the website, is we have a page so that you can go and look up when the various data products are available. For some of them, some of our data products are available all the time, but some of them are only turned on when the spacecraft is in particular modes. And this allows you to find out when you can get those products. This is just an example of this. And yeah, you just think this is a link off of our FEMIS website.
Well, this is very powerful, actually. It could bring up any other mission, like POST, GOES, that we support. And then you can see when that particular mission has data in a color bar like this, relative to when an instrument of things will operate. So you can see, you can zoom in and out and pan right or left in any year, month, day.
Find conjunctions of data on multiple spacecraft. Maybe good times to investigate. So I think this covers some of the stuff from your question, but we're trying to make this as usable as possible. We provide the command line interface and the graphical user interface for different types of users, and also people that have, depending on what sort of IDL licensing you have. Yeah, and this is sort of, these are what we test on when we do our quality assurance testing, which is basically before every release, we have a bunch of automated scripts that run, and we try to run them on these different platforms to verify that they all work. Although our Solaris support is probably lapsing, that's getting less and less common. Is that accurate?
Yeah, but they're
We sort of spot check Solaris at this point.
once in a while. Yeah, this is almost all is native IDL. So as long as IDL fully supports that platform, almost everything will work.
Yeah, I mean, we do find some differences from operating system to operating system, but your odds are pretty good. So this is a little bit different than the previous organization. When you download the software, you're going to get your top level directory is going to say IDL. And if you go into that, you're going to get these subdirectories for basically for different parts of the software. So projects is where the Themis project lives. I didn't show all the other projects, but there are a bunch of other project directories that live here too for other projects that are working in the SpeedS framework. SpeedS is for sort of SpeedS general routines. Right now it contains the SpeedS GUI. General is all of our core command line routines. So these are some of the routines that have been developed for a really long time, and that we sort of use to do a lot of our high performance IDL tasks, stuff that's not built into IDL, but is very necessary to get stuff done.
People live there.
Yeah, T-plot lives there, and stuff for doing like structure manipulation and different sort of core analyses like FFTs and wavelets. Those will be in general. And external is for code that is that needs some other sort of support generally. So like for the C2Web or for the SIG and Yanko models, you need to have external software components that you install. And so they live in the separate directories and sort of port them off. And if you don't have those, the stuff in external won't necessarily work. System requirements, I think we mentioned that you're going to have a hard time with IDL 6.2 these days, but you can try it. Yeah, and you can get the user's guide from the link I showed you on the website or from this link right here. To install it, you just download it. You unzip it, and then in your IDL, you just say preferences paths, and you insert the location of wherever you unzipped it. And that's that. If you're doing it, you can also set the data directory. It'll pick a default, but if you, for example, running UI config, that gives you a little GUI to change it. But by default, when you download data, it's going to go C:\data on Windows and ~data on Linux or Unix. So yeah, we sort of have this this directory level organization for how we store things when we download it. So the basic idea is that most of this data lives a lot of different places. It's in CDF files that are maybe at Space Sciences Lab in Berkeley, or they can be their mirror sites, so copies of the Themis data that live at UCLA, or I think there's one in Japan, right?
That would maybe be inoperative. I think there's another one in France that's operational.
Yeah, so people are copying the data. You know, if you're having internet problems, you can point at another one of those repositories. And then for other missions, you know, for say like C2Web data or GOES data, they might be at a different location. And then what we do is we don't download all that data when you first install the software. When you request some data, it downloads it and stores it locally. And so the first time you download it, it may take a little while, but after that, when you reuse the data, it just checks to see if the data's changed, and if it hasn't, then then it just uses your local copy, which is in that data directory I mentioned. That saves you because you don't want to have a huge amount of data on your computer and a gigantic hard drive. It saves you in download time and pretty efficient. So let's see. We mentioned data levels. Just generally, when you're using the different load routines, you're going to request a data level. SST needs to be the exception. You'll request a type, probe. Sometimes you may want to request support data, which is not necessarily like the science data, but things like, for example, for our ephemeris, you have the location of the spacecraft, but the support data would be, say, the phase of the spacecraft and the spin, which is useful for performing different calibrations. And depending on the instrument type, there'll be different types of support data. If you were just in your IDL command line, after you've got your path set, you can run this immediately. So you would just type this to set the range of interval that you're interested in, and then this command would load some ephemeris data. Whoops. And then this command would load some magnetometer data. You can load it in your preferred coordinate system, the coordinates that we support, and the particular type for the instrument. So this is, our FGL is considered our low resolution data, although it's higher, that's time resolution. It's higher time resolution than SpinFed. But it's not available for the entire mission, so you would want to check that tool we showed you earlier to check for availability. I mean, if it's not available, the tool won't crash. It'll just tell you, you got to load data off. So we use sort of, within Themis, we use a particular set of naming conventions. The mouse keeps screwing up, so I'm going to go with so there are 5 Themis spacecraft, A through E, so you can specify a probe letter. And in our names almost always start with TH and then a probe letter. Sometimes for ground data, it will be THG for our ground magnetometer ASI data. If it's particle data, then there will be an underscore and then a particle, and then an E or an S for SST, or ESA. And then after that, ions or electrons. And then after that, you have the data type, which is sort of, for particles, it's a compromise between angular resolution and time resolution. For our field resolution data, for our field data, it's generally just a time resolution trade-off. And if you're requesting data or plotting data or using our tools, when you're typing these names, so the variables that get loaded when you load data using the load routines will have these sorts of, will have names like this. And if you want to do an operation on multiple ones, you can use wildcards. So a question mark would say, like, do all of the probes that you have loaded. And question mark here would say all of the different types of FGM data resolution that you have loaded. You can do these things, the brackets to specify a subset, or a star, maybe just grab any strings matching, any variable strings matching after a state. Is that a question? Okay. This is a load routine summary. These are the names of the actual command line IDL routines, and then the levels of data. So the way that we document for the command line is we have these things called cribs, which will be in the directory Themis examples. And basically, it's an IDL file that you open up and you can just run. And it'll have lots of comments, it'll have examples. A lot of them were written by people on the various instrument teams for Themis. So you have very knowledgeable people trying to tell you about all of the different pitfalls that might happen when you try to use a particular data type. Also, we have what we call analysis routines, so like FAC, that's field line coordinate transformations. Some other ones like different plotting options. This is a particular way to plot. This is to do what's called waveform analysis.
Yeah, we had a question about polarization. That crib sheet would be the one to look at.
Cool. So basically, you can open it up and just, click run in the GUI, or you can type .run in the name, and it'll run it and do some stuff. I'll show an example of how you would go about doing that.
Is there any documents of this subroutines?
I mean- I mean, these sort of are the documentation. We have these in directories, and you look at these, and we write lots and lots of comments in them to say, like, intro materials. This is how you use it. This is sort of our primary mode of documentation.
And we have them separated. Like we have a basic directory, which is like the basic operations, and then I think we have an advanced crypt directory, which are the more complicated types of analysis. So if you're just starting, you probably start with the basic crypts, which are like the load routines and the different options for load routines, and then they get sort of progressively more complicated.
These are all functions, right? These are functions.
These are procedures.
Procedures.
Yeah.